All right, let's go ahead and talk about the problem of the day. Be sure to answer the questions that I ask out loud. Do you know what the difference is between weight and mass? Say it out loud if you do. Yeah, weight is how heavy something is. So for example, this container of Play-Doh, it's heavier than this tape dispenser. The Play-Doh feels heavier when I hold it. I have to use more strength to hold it up. So here we've got our definition of weight, right? Weight measures the heaviness of an object. Mass is related to weight, but mass measures the amount of matter or stuff in an object. How much matter the object contains. When objects have more matter on Earth, they feel heavier. So here's an example. We've got a coffee mug and a red plastic cup. The coffee mug has more matter or stuff that's used to make it up, so it has more mass. And we know this because it feels heavier, so it's also got more weight than the red plastic cup. On Earth, mass and weight are essentially the same thing. When objects are in outer space, however, sometimes they float. Why is that? Say it out loud. Yeah, there's no gravity in space, is there? So when the gravity changes, that means the weight of the object is less. So weight can change based on gravity because objects can feel more or less heavy in different places. But the amount of matter in an object doesn't change, no matter where that object is. Again, we can think about mass and weight as the same on Earth, because on Earth, the more mass something has, the heavier it's going to be. So here we have, right, weight changes based on gravity, mass does not change. And our key point here about on Earth, you can think of them as the same thing. All right, so let's talk about our units of weight and mass. So our customary units are for weight, and our smallest customary unit is an ounce. A pencil is a good benchmark for an ounce. Say pencil ounce. Great. I'll go ahead and draw a picture of a pencil here. Here's our eraser. Great, there's our pencil. Okay. What is the next largest unit of weight? Say it out loud. Yeah, a pound. So a shoe is about 1 pound. Go ahead, you're going to say shoe pound. Go ahead. Yes. So we'll come to our chart. We're going to draw a shoe. And there are 16 ounces in 1 pound. Great. And what is the largest unit of weight? Say it out loud. Yeah, it's a ton. And actually, a small car weighs about as much as a ton. There's our funny little car. How many pounds do you think there are in 1 ton? Say it out loud. Yeah, there's actually 2,000 pounds in 1 ton. Awesome. Okay. So then there's also 2 metric units that we're going to talk about. And the metric units are used to measure mass. So our smallest unit is a gram. A gram is about the size of a paperclip. Right? So a paperclip has about the mass of a gram. Go ahead and say paperclip gram. Okay, I'll put that here. And we'll note that. Great. The other unit is a kilogram. Now a kilogram, or a benchmark for the kilogram, is a textbook. Okay, here's a textbook. So go ahead and say textbook kilogram. All right, so we'll add that to our visual anchor. Now, based on what you know about the metric system from the past couple of days, how many grams are there in 1 kilogram? Say it out loud. Yep, there are 1,000 grams in 1 kilogram. How did you know that? Say that out loud. Right. It's just like meters, right? There were 1,000 meters in 1 kilometer. There's 1,000 grams in 1 kilogram. It's a nice thing about the metric system that it's consistent in that way across different types of measurements. Okay, so now we're ready to estimate. What thinking questions have we been using to help us estimate? Say them out loud. Yeah, just like we did for length and capacity, we think about the object of the benchmark and we think about what unit makes sense. Because we're talking about weight or mass, it can be helpful to think, is the object heavy or light? Once we've picked our unit, we ask ourselves, how many of the benchmarks for that unit do I need? So if we're measuring something in grams, we would think, how many paper clips would it take to weigh the same as the object that we're measuring?